Hello, class, and welcome to the second day of lesson 6.6. Now, on the first day, we talked about matrices and we talked about how we can use row operations to create again the row echelon form of a matrix. And while I did, let me go down to it. And while I did a very simpler, shorter version of it, we didn't go over longer versions of it, just so you could again see again how this works, how the row operations can create what again is referred to as the row echelon form of a matrix. And then using that, we can follow steps again. Will take a bit longer to write a matrix in row echelon form, which will look again like this. And we talked about how we can use then backward substitution in order to evaluate and determine the values of the system of equations when it's already in the row echelon form, by writing each row, starting with the bottom, into an equation. So we have here in this bottom equation that 1z is equal to 2. From the middle row, row 2, that we have 0x is 1y minus 1z equals negative 3. And using substitution, knowing that the value of z is 2, we can substitute in that value and then solve the equation. And do the exact same thing using row 1. So with row 1 being this equation here, x minus 1/2 y plus 1 over 2, that's a 2 right there, z equals to 5 over 2. I can replace the y value and the x value with 2. And that again is referred to as the Gaussian operation, okay? Gaussian elimination operation, using these row operations in order to create again this row echelon form of this matrix. Well, later this mathematician did a collaboration with this other mathematician named Wilhelm Jordan, and they continued the process into the matrix with only the ones being the main diagonals and everything else being zeros. And this is the reduced form of the row echelon form. So by using again these row operations, we're able to create again these reduced row operations, which if we look at the equation, each row translates that the value of 1x, 0y, 0z is going to equal to this value of a. From the second row, 0x's, 1y, and 0z's is going to equal to the value of b, and then 1z equals to the value of c. So instead of doing backward substitution, we can continue the row operations in order to create, like I said, this reduced row echelon form of the matrix. So let's begin by first distinguishing yet again the difference between a row echelon form and the reduced row echelon form of a matrix. So the row echelon form of a matrix, and we'll do this in terms of columns. The first column is going to start off with the element in the main diagonal, E11, to be the value of 1. And then the elements underneath it, assuming again that we're doing a 3 by 4, I'm going to focus just on a 3 by 4 matrix, will look like this. Then the second column would have the first element in that top row there be some random number, where the second number will be 1 and the number down at the very bottom would be 0. So we end up with the second elements and element E, second row, second column to be 1 as well. And then on the third column, we'll have the first element in the top column be some random number, another random number there, and 1. So you see, and then of course, these numbers over here would be some random numbers there, would just be some values, okay? And what makes this in echelon form is that in the main diagonal, all of these values are going to be 1s, and the values underneath are going to be 0. So 2 zeros under the first column and a 0 under the 1 in that second column. Now, by performing again the row operations that we discussed yesterday, and to make these values up there equal to 0, that's going to create the reduced row echelon form of the matrix. And that format will look like this. So just like the row echelon form, our main diagonal is going to be just a bunch of 1s. And the elements underneath would be zeros along with the elements up there. Those would have to be zeros as well. So this would be the reduced row echelon form of the matrix. Now, because the row operations, again, are going to be long, in order to write our matrix in the row echelon form, I'm going to show you how to use a Desmos matrix calculator in order to write our matrix in this RREF, in this row reduced echelon form, to solve the system of equations. Now, the only skill that you'll be required to know and to use is the same skill we practiced in the last part, on the first part of this video, of this section here, which is writing a matrix from a system of equations. So here I'm going to go by columns. In the first column, the coefficients for x are 3, 4, and 2 for equation 1, 2, and 3 in that order. For the coefficients of y are 2, -5, and 3. Then for z are 3, 7, and -2. And our augmented matrix will finish off the last column with 3, 1, and 6. So let me show you how to use the matrix calculator to figure out the reduced row echelon form of our matrix, which is RREF of this matrix A. So it's an acronym form. So here is the matrix calculator I'm referring to. You can find it under the website. The web address is desmos.com/matrix. I embedded it in your homework assignment, so you'll find it again under your resources there. And let me show you how that works. You'll start by first creating a new matrix. And the dimensions, again, is a 3x4 matrix. 3 rows, 4 columns. And we start by obviously entering the elements in the places of those zeros. So we have 3, 2, 3, and 3 in the first row, 4, -5, 7, +7, and 1 in the second row. And on our third row, we have 2, 3, -2, -2, and 6. Okay, so we're going to hit enter. And now what we need to do is, remember, get the reduced row echelon form, which you'll see that command is down here at the bottom of the keyboard right here on the left. So clicking on that, we'll get the parentheses, and we just simply have to type in the letter A because that A is stored as that matrix. So here, and voila, the calculator does all the row operations for us instantly and tells us that the value of this system of equations is that the value of x is 2, y is equal to 0, and the value of z is -1, this column right there of elements. So there is your answer using this matrix calculator. Now you can also get to this command, those of y'all like typing stuff instead of clicking on things, you can also type in the command row reduce echelon form and just include the parentheses yourself, and then again the name of the matrix. If you do a second matrix, then it'll just move on to the next letter in the alphabet and again go with B. So if you don't want to delete everything or clear everything and just want to continue from where you left off and do another problem like this, you could just simply continue there and just use the appropriate name. So if you have this matrix, hit enter, but you do a second matrix and you want to do the row reduced echelon form of matrix B, you have to make sure again that you type in matrix B and not A. So here we have again our solution. So again, in the reduced row echelon form, that is always going to look like this. And on the last column, we got 2, 0, and -1. So those are your solution. The value of x is +2, the value of y is 0, and the value of z is -1. So for the last example, we do something very similar. Again, we're going to write this as a matrix. I'll call it again matrix A. And the elements for matrix A going down the columns are -5, +5, -5. Second columns will be elements 6, 2, -3, 4, 6, -1. And in the fourth column, -22, -8, and -7. And then using again the Desmos calculator, we're gonna get the reduced row echelon form of our matrix A, which would be that format there, and then plugging it into the matrix, you should end up with these values there. So double check again that you get those numbers. Test again that you know how to use the matrix calculator, the calculator correctly. And the only real big mistake you could actually do here is typing in the wrong number. Okay, typing in not correctly translating our system into our augmented matrix. So the answer again is that x equals positive 2, the value of y is 0, and z equals negative 3, which as a intersection, as a point, as a coordinate, would look like this. Okay, in order. So this is not technically an ordered pair. Pair means only 2, but this is still going to be in alphabetical order. X, Y, and Z. So now this concludes the second part of lesson 7.6, using matrix and Gaussian elimination to solve systems of equations. I hope you found this video helpful, but if you do have any questions or stuck with any of the homework problems, please message me through email, Parent Square, or on my Open Math on Message the Instructor. I appreciate you watching, and I hope you have a good day. Goodbye, everyone.